In this video, I will be sharing with you how to build a platformer game in Python. This game will have pixel perfect collision, it will have an animated character as you can see here, it will have single and double jumping, it will have all kinds of different animations for falling, jumping, colliding with obstacles. For example, you can see here when I hit the fire, I kind of go into this hit state. I will show you how to generate different objects, how to scroll the background, and really at the end of this video, you will have a solid fundamental understanding of how to build a platformer game in Python, and you can go and extend this and build really anything that you can think of. I will even include a ton of free assets for you that allow you to change your character, change the terrain, change the background, and do all of that extremely easily. In fact, in this tutorial alone, I will show you how to use 4 different characters. Let me show you those characters before we continue. So this is the second character here. This is being referred to as Mask Dude. This is the third character. I'm calling this guy the Ninja Frog, as you can see. And finally, we have this character here, which is called Pinkman. Now, in this tutorial, you will learn how to use all of these characters, and you can swap them out with a single line of code. With that said, I hope you're excited. This video has taken a very long time to prepare, so please click the like button, subscribe to the channel, and we'll dive in after a quick word from our sponsor. Thanks to Dice for sponsoring this video. Dice is the platform for go-getters like yourself to find your next job in tech that aligns with your values and skill set. On Dice.com, you can easily search and filter for jobs and set personalized alerts so you never miss a job opportunity. Start by creating your free profile, setting up your job alerts, and then going visible and connecting with employers immediately. Now, beyond just landing a job, Dice helps you gain insights into the tech industry and learn what skills and technologies you need to master to get to the next level. With Dice.com, you get access to countless articles, free ebooks, and a variety of other resources that help you understand things like what tech salaries you can expect, job postings by volumes, the number of jobs by occupation, and a lot of other valuable information that helps you craft your career in tech. We all know that searching for a tech job can be difficult, but with Dice, it doesn't have to be. Click the link in the description to start leveling up with Dice today, and don't forget to download their mobile app so you never miss a great job opportunity. Thanks again to Dice for sponsoring this video. All right, so let's go ahead and get into it. Now, since this is a long video, I do want to spend a minute here just talking about who this video is designed for, exactly what you're going to learn and what you can expect, just so you don't waste your time if you don't want to go through it. So this video is really designed for people that have a bit of experience with Python. Ideally, you are an intermediate Python programmer. You understand the syntax, you know for loops, you know functions, you know all of that. If you don't, feel free to follow along, but I'm not going to be explaining those basic concepts. Now, this video will teach you how to build exactly what you see here. So by the end of the video, you will have exactly this. And if you're not interested in waiting until the end of the video, then you can download the code from the GitHub repository that I will leave in the description. That's also where all of the assets are going to be. So regardless, you're going to have to download the code from GitHub. Again, I will leave that in the description. Download that, open up the folder, and kind of we can start working from there. Now, really what I'm going to be showing you here mostly is sprite sheet animation, pixel perfect collision using what's called masks, and then how you can do the scrolling background, generating objects, all of that kind of stuff. That is really the hard part when it comes to generating a platformer game. Once you have all of that down, it's very easy to extend this, to add levels, to add a finishing flag, to add coins, to add, lives. You can turn this game into anything you want, and that's how I've designed this so that you have the base, and then you can go and make it kind of a full-fledged game and work off of that. So with that said, I will stop talking now. I think this game looks really good. I'm excited to share this with you guys, so let's get into actually building it. So right now I have Visual Studio Code open. Obviously we're doing this in Python, and I already have Pygame installed. Now the first thing we're going to have to do is install Pygame, which is the module we're going to be using. So to do that, go to your terminal and type pip install Pygame. If that doesn't work for you, you're going to try pip3 install Pygame. If that doesn't work, try Python -m pip install Pygame. If that doesn't work, try Python 3-m pip install Pygame. If none of those work, I will leave 2 videos on the screen that show you how to install that module. Now, once you have Pygame installed, I'm going to assume that you've downloaded the GitHub repository. Go to GitHub, there's a little button that says click to download the folder, extract it to your desktop, and then open it in VS Code or whatever editor you want so you have something that looks like this. You should have an assets directory. Inside of assets, you should have a bunch of different folders, and then you should have a main Python file that contains all of the finished code. Now, obviously, we're going to write the code from scratch, but you can either work off that existing code or you can kind of clear the file and type along with me, whatever you want to do. I quickly want to run you through the assets folder, and then we'll get into the code. So in assets, we have a ton of stuff. We're not going to use most of this, but I wanted to include all of it so that you could kind of continue the game later if you want. So we have, for example, backgrounds. These are a bunch of background tiles, so you can change kind of the theme or color of the background very easily. I'll show you how to do that. We have items like boxes, checkpoints, fruits, etc. We're not going to use any of those. Then we have main characters. For main characters, we have a bunch of sprite sheets inside of here, and I'll show you how we can split these sprite sheets apart and use all of the different kind of animations inside of here, right? So we have that for Mask Dude, Ninja Frog, Pinkman, and Virtual Guy. All of the file names are the exact same. Okay, then we have menu. We're not going to be using anything from there. We have other. We have terrain. We are actually going to be using terrain. Specifically, we're going to pull out this kind of block here, but you could change the block again if you want to do that. And then we have traps, and we are going to be using the fire trap, wherever that is right here, that has kind of an animation, right, where the fire is going. But again, you can add all of this stuff later on. I will show you kind of the base on how to do it, and then you'll be able to extend from there. Okay, now that we understand the assets, I apologize for such a long introduction. Let's get into writing the code. I also need to plug that I do have a course, programmingexpert.io. If you guys want to get better at Python, check that out from the link in the description. Okay, so let's start at the top of our program here by importing everything we need. We're going to import OS. We're going to import random. We're going to import math. We're going to import Pygame. We're going to say from OS, import list directory. And we're going to say from os.path, import isFile, and join. Now, the reason I'm doing all this OS stuff is because we are going to be dynamically loading all of the sprite sheets and the images so that we don't have to manually like type out the file names that we want. I'll show you how we write a function that just loads these folders here, kind of splits the sprite sheets automatically and gives us all of the images that we're interested in. Okay. After we do that, we're going to say pygame.init. We need to initialize the Pygame module. Then we're going to go down here. We're going to set a caption for our display. I'm going to say pygame.display.set_caption. If you're unfamiliar with what this is doing, this is setting the caption at the top of the window. I'll try to explain most of the Pygame stuff as we go through the video. I also have a ton of videos on Pygame on my channel if you want to check out something a little bit more basic. Okay, now what I'm going to do is define a few global variables that we're going to be using here. The first one is going to be the background color. Now, we'll use this for now until we implement our own background. And for the background color, I'm going to make this white, which is going to be 255, 255, 255. All of our colors in Pygame are going to be in RGB. Okay, so red, green, blue. That's what we have for our background color. We're then going to define the width and the height of our screen. For some of you, you're going to have to make this smaller if you're on a smaller display. For me, I'm on a 2K monitor, so I'm going to go with 1000 by 800. But if you're on, again, a smaller screen, you might want to make this just a bit smaller so that it works for you. Although it doesn't really matter, make it whatever size you want. Next, I'm going to say my FPS, which is my frames per second, is going to be equal to 60. And I'm going to define my player velocity equal to 5. And this is going to be the speed at which my player moves around the screen. Okay, now that we've done that, we need to set up a Pygame window. So I'm going to say pygame.display.set_mode, and then I'm going to pass the width and the height to this window argument here, this mode argument, and this is going to kind of create the Pygame window for us. I'm going to store that in the window variable, and there we go. We have kind of our global variables created. Now I'm going to make a main function. I'm going to say define main. This main function is going to be what we run to kind of start the game. So inside of here, I'm going to take a window, and at the bottom of my program, I'm going to say if __name __ is equal to __ main __, then call the main function and pass the window argument. Okay, so hopefully you can see kind of the structure of our program already. The reason I have this line right here is so that we only call the main function if we run this file directly. If we don't run this file directly, say we imported something from it, then we won't run the game code, okay? So that's why I have this. Inside of main is where we're going to write kind of our event loop. The event loop will be what's handling, say, the collision, moving our character, redrawing the window, all of that kind of stuff. This kind of good practice to have your event loop in one place. So inside of the main function, we need to set up a few things. The first thing we need is a clock. So we're going to say clock is equal to pygame.time.clock. We also need to define, a while loop that's going to continually loop and act as our event loop. So I'm going to say run is equal to true. I'm going to say while true, or while run, sorry. And then the first thing I'm going to do is say clock.tick FPS. Now FPS, remember, is our variable right here. What this line does is ensures that our while loop is going to run 60 frames per second. Okay, so no more than 60 times per second. That's what this ensures. If you're on a really slow computer, chances are you could be running less than 60 frames per second. But in my case, I'm on quite a fast computer. And if I didn't put this here, then you'd see that my game would be like way faster than yours. So we need to do this to regulate the frame rate across different devices. Okay, now that we have that, we're going to say for event in pygame.event.get. And the first event that we're going to check for is if the user quits the game. If they quit, by quitting, I mean they hit the red X in the top right hand corner, then we need to stop the event loop and exit our program. So I'm going to say if event.type is equal to pygame.quit, then we're going to say run is equal to false, and we can break out of this loop. Then we can go down here and we can say pygame.quit. Notice this is outside of the while loop. And then we can put quit, which will actually quit the Python program. Okay, so now we have our basic event loop. And what should happen if I run the code now is a Pygame window should pop up. Nothing should be on the screen. And if I hit the red arrow, it should close. So let's try this and see what we get. Okay, notice it says platformer, and then I hit X and it closes. Perfect. We're well on our way to creating the platformer game. All right, so now that we've done that, I actually think that the first thing we can do is generate our background. Then once we have the background, we can create a basic player that we can move around the screen. And once we have that, we'll start doing all of the animations. And then later in the video, once we've got kind of the bulk of the stuff done, we'll handle the collision and all of the movements, right? Okay, so I need to make a function here, and I'm going to call this get_background. Now, before I dive into this, let's have a look at our assets folder again. Now, what I want to do is use these tiles, right? They're just tiles. I believe their size is 64 by 64 or 32 by 32, something along those lines. Anyways, we'll want to use these tiles and tile the whole background. So what I need to do is essentially create a whole grid of these tiles based on the size of my screen. So the way I'm going to do that is by using a folder here. This folder is going to return to me, sorry, not this folder, my bad, this function. This function is going to return to me a list that contains all of the background tiles that we need to draw. So that's what we're going to do here with get background. Now, what we want to take is the name. Sorry, as I was saying, the name is going to be the color of our background, and that's going to allow us to change what background that we're using. So the first thing we need to do here is load this background image. Now, it's very important that when you run this file, you run it from the directory that the file exists in. Now, the reason I'm saying that right now is because the way I'm going to load this image relies on the fact that you're running this code from the directory that it exists in. So see here that I'm in desktop Python platformer, and then notice tutorial is inside of that directory. That's why this is going to work. If you try to run this code from a different directory, say I cd to desktop, and then I tried to run this, then I'm going to get an issue. So just make sure you're in the correct directory. I just want to say that before we even get into this. Okay, so I'm going to load my image. I'm going to say image is equal to pygame.image.load. And then what I'm going to do is join the assets path, which is directly in the directory this file is in, with the backgrounds path here, if I spell background correctly, and then with the name, which is going to be the file name that I want to load, which is really just the color of the background. Okay, now that I have that, I want to get the width and the height of this image, so I'm not guessing what it is. So I'm going to say __ width height is equal to image.get_rect. Now, when you do this, it will give you the x, y, width, height. I don't care about the x, y, so I've just put 2 underscores here denoting that I don't care about these values. And then I'm able to grab the width and the height. So now that I have the width and the height, I'm going to say tiles is equal to an empty list. And then I'm going to loop through essentially how many tiles I need to create in the x and the y direction. So I'm going to say for I in range, and then I'm going to take my width, I'm going to integer divide this by the width of my tile, and I'm going to add 1. And then I'm going to do the same thing for my height here. So I'm going to say for j in range height over the height of my image plus 1. Okay, so notice width here is the width of the screen. Height is the height of the screen. I'm integer dividing this by the width of my tile, and that tells me approximately how many tiles I need kind of in the X direction to fill the whole screen. Then, just to make sure that I don't have any gaps, I add 1, and I do the exact same thing for height in the Y direction. Then what I'm going to do is say, actually, yeah, I'm going to say rect. Is this rect? No, we're going to say pause is equal to I multiplied by the width and j multiplied by the height. And this is going to denote the position of the top left-hand corner of the current tile that I'm adding to this tiles list. In Pygame, when you draw something on the screen, you draw it from the top left-hand corner. So what I'll be doing is continually moving the positions based on how this for loop is going, right? So for every I, for every j, I'm multiplying it by the width and multiplying it by the height, and that gives me the accurate positions that I need to place every single tile in on the screen. Hopefully that makes a bit of sense, but that's how this is working. And then I'm going to say tiles.append my position, and then I'm going to return my tiles. I'm also going to return the image so that I can know what image I need to use when I'm drawing all of these tiles. Okay, now that I have my background, I'm going to go into main, and I'm going to say my background is equal to get background. And for the name, I'm going to reference here in the background folder any of these images. So we can use any one we want. It doesn't really matter. I kind of like the blue one, so I'll go with blue. Feel free to change this, though, on your end. And there we go, if I can type this correctly. Okay, so I'm going to say background, comma, BG image like that. And now I want to set up something that's going to draw my background. So I'm going to make a function here, and I'm going to say draw. This is going to take in a window. And for now, it's going to take in a background, and later it'll take in everything else you want to draw. Inside of here, I'm going to say pygame.display.update. And before I do that, I'm going to draw my background. So I'm going to say for, and this is going to be tile in background like that. And then I'm going to say window.blit. And actually, I need to take my BG image as well. So let's take that. And I'm going to draw the background image. And then what I need to pass here is the position I want to draw it at, which is going to be tile. So what I can actually do is just convert this to a tuple. Notice the tile is going to be a list, right? Tile is going to contain kind of my XY position. You can see that here, right? We're appending pause, which is a list of XY. And now that I think of it, to make it easier, let's just make this a tuple directly. And now we don't need to convert it. Okay. So in case anyone's confused, what we're doing here is looping through every single tile that we have, and then we're going to draw our background image at that position, which will fill the entire screen with background images. Then what we're going to do is update the display. The reason we update is so that every single frame we kind of clear the screen, right? And we don't have old drawings still on the screen. You'll see what I mean in a second, but this draw function is where we're going to do all of our drawing. For now, the only thing we need to draw is the background. Later, it will be the player, the blocks, the obstacles, etc. Okay, so now I'm going to go inside of my while loop, and I'm going to call this draw function that we just created. And I'm going to pass window, and then, of course, I'm going to pass my background and my BG image. Okay, now this reminds me that I no longer need this background color. We're not going to use that, so I can get rid of that there. Okay, so at this point, assuming I've loaded the image correctly, we're now going to see this tiling the entire screen. So let's save and run. And notice that we get it, right? It's tiling the entire screen, looks pretty good to me. And we can quite easily change this if we want by just going here and saying, okay, rather than blue, I want yellow. And then we say yellow, and now we get a yellow background. Great. So that's kind of the advantage of how I've done this here. You can change the background to any color you want. Well, given that it's in the background directory. Now that we have our background, what should we do next? Well, we probably want to put a player on the screen and start seeing some images for that player. Now, the player itself is the most complicated aspect of this program. There's a lot of movement going on with it. So we'll start by just creating like a block for our player, kind of move the block around, have it jumping around. Then once we do that, we'll do all of the sprites and animations just so that we can get some more progress before we dive into that, because it is a bit of work. Okay, so let's go here. And let's say class player. We're going to use a class for our player. It kind of makes sense here. And this class is going to inherit from pygame.sprite.sprite. Now, I don't typically use sprites when I'm working in Pygame, but I'm going to use them in this tutorial. And the reason for that is that it makes it very easy to do pixel perfect collision. When we have two sprite objects, which we're going to have because we're inheriting from the Pygame sprite class, we can use a method that tells us if these sprites are colliding with each other. So just understand that's why I'm doing this inheritance. You don't have to understand exactly what the sprite is, but it kind of denotes that we have some properties on our class, and then it allows these special Pygame methods to use those properties to handle the collision for us. So we don't have to write anything too complicated when it comes to the collision, although we still do need to handle it a bit. Okay, so what we're going to do here is define our initialization, and we're going to take in a self, an x, y, width, and height. Now, the width and height will really be determined by the image that we're using for our player. But for now, since we're going to have like a block for our player until we add that image, we're going to have a width and height. Now, that reminds me that I just need to set a color for my player. So I'm going to say color is 255.00. I'm making this a class variable just so it's the same for all of my players and I have access to it just right on the class. Okay, now what I'm going to do is say self.rect is equal to pygame.rect. I'm going to pass my x, y, width, and height. So rather than representing all of these values individually, we're just going to put them on the rectangle, and this is going to make it a little bit easier for us to kind of move the player around and do collision and all of that. So a rect really is just a tuple that's storing 4 individual values. When I make it pygame.rect, it means we can use it in some kind of special equations and whatnot. Okay, now for our player, we're going to have a few values. The first thing we're going to have, I'm getting a bit ahead of myself here, but is going to be the x velocity. And the next is going to be the y velocity. Now, the x and y velocity is going to denote, what do you call it here? How fast we are moving our player every single frame in both directions, right? So the way that we'll actually move our player is we'll just apply a velocity in a direction, and then it'll just keep moving in that direction until we remove that velocity. Now, this will be great, for example, for something like gravity or jumping, and you'll see what I mean in a minute. Okay, now that we have that, we need to add something known as a mask. For now, I'm going to say the mask is equal to none, and then I think that's all we need for right now. So now that we have that, let's add our first function here, which is going to be the move function. So move is going to take in a displacement in the x direction and a displacement in the y direction. And it's going to say the self.rect.x plus equals the direction x, or displacement x, sorry, and self.rect.y plus equals the displacement y. Now, if we want to move up or down or left or right, we just change the sign of this dx or dy, right? Okay, so now we have move. Next, what we want to do is create 2 functions, one for moving to the left, and this is going to take in the velocity we want to move in the left direction, and the next is going to be moving in the right direction. Again, this is going to take in self and vel. Now, to move left, what we're going to do is say our self.x velocity is equal to, and then this is going to be negative velocity, and then to move to the right, we're going to say self.x vel is equal to vel. Now, the reason we use negative velocity here is because if we want to go left, we have to subtract from our x position. In Pygame, remember, our coordinate system is that 0, 0 is the top left-hand corner of the screen. So if I want to move down, I add to my y coordinate. And if I want to move to the right, I add to my x coordinate. So if I want to go up, I subtract y. If I want to go left, I subtract x. So that's why I'm putting a negative vel here. I know it seems a bit weird how I've just done move, and now I'm saying move left, we're going to have negative. Don't worry, you'll see how this works in a second. Next, I'm going to say if self.direction does not equal left, then self.direction is equal to left. And I'm going to say self.animation count is equal to 0. Now, we're not going to use these right now, but I just want to add them in for now at least, and you'll see why in a second. Now, I'm also going to say up here self.direction is equal to left. And the reason I'm adding this direction is because I need to keep track of what direction my player is facing. So later, once I have my sprites, I know if I'm showing the animation to the left or I'm showing the animation to the right. Now, the animation count, we're resetting that when we change directions. And the reason we're doing that is so that the animation doesn't look all wonky when we go from going left to right. So we need to kind of reset the count that we're using to change the animation frames. Again, you're going to see that later as we go through the tutorial. Now I've just added up here self.animation count equals 0, just to make sure we don't get any weird errors later. So now I have my direction and my animation count. Perfect. Okay, now I'm going to copy this. I'm going to put the same thing in move right, and I'm going to change the direction here to say right, and then right. So now we know what direction we're facing at all points in time. Okay, perfect. Next, what we need to do is we need to have some kind of draw function, and we also need to have what I'm going to call the loop function. And in fact, let's do the loop function first. So I'm going to say define loop, and inside of here, I'm going to take in self and FPS. Now, what loop is going to do is be called once every frame. When I say frame, that's really one iteration of the while loop. And this is going to move our character in the correct direction and handle things like updating the animation and all of the stuff that we constantly need to do for our character. So for right now, I only care about moving in the X direction. We'll handle the jumping later. So what I'm going to do is just say self.move. And I'm going to say that we're going to move based on our X velocity and our Y velocity. Now notice we're updating our X velocity here when we move left or we move to the right. So now if we call loop and we have some velocity in the X direction, it's going to move our character to the left or to the right. Okay, again, all this will start to make sense as we get through the tutorial. There is a lot of stuff I need to do kind of up front before I can just show you instantly. So hopefully you guys are following along, but I just want to note, we eventually, of course, will see how all this works. I'll walk through the code, so no worries if it's a bit confusing right now. Now, what else do we need to do inside of loop? Well, we need to update something known as the mask, which I'm going to get to in a second. But before we can do that, we need to define what's known as our image. So I'm going to say define, and this is going to be draw, and this is going to be the function that handles drawing on the screen. And for draw, we are going to take in our window, which I'll just represent with win. Now, what we'll do for now is we'll just say pygame.draw.rectangle. We'll draw the rectangle on the window, which is the first argument here. It's where we're drawing it. The second argument is the color, which is going to be self.color. Then the last is the rectangle. So I'm going to say that is self.rect. Now notice the rect here, right, has our x, y width, height. And when we move, we're updating the x and y of the rectangle, which will then change where we're drawing it, if I can find it here, on the screen. Okay, so that's what we need for drawing. Now, actually, for now, I think that's okay. We will add to this, obviously, in a second, but I think we can generate a player, draw the player, see it moving, and then go from there. So let's do that. So let's go to main here. I'm going to create a player. I'm going to say player is equal to player. I need to pass an x, a y, and a width, and a height. So I'm going to pass, let's say, 100, 100, and let's make him 50 by 50. And then what we can do now is pass our player to the draw function. We can then take player inside of here, and we can say player.draw, and we can pass the window. Okay, so I will move the player in 1 second, but for now, let's just see if this is working, if it's going to show up on the screen. So let's run the code. And notice that now we have a red rectangle in the top left-hand corner. Obviously, nothing's happening right now because we're not moving it around the screen, but you could see it's showing. So we have our player, we're drawing the player on the screen. Now we want to start using some of these methods, right? Moving left, moving right, etc. So I want to separate my movement into a function. So I'm going to say define handle move like this. And for this, right now, we'll just take in the player. Now inside of handle move, what we're going to do is essentially check the keys that are being pressed on the keyboard. If you're pressing left or you're pressing right, then we'll move the character to the left or to the right. Eventually, we will check for collision and we will do all of that. So I'm going to say key is equal to pygame.keys, actually not keys, .key, .get underscore pressed. This tells you all of the keys on the keyboard that are currently being pressed. And I'm going to say if, and actually this is going to be key. Really, we should call this keys though, because this makes a bit more sense. So we're going to say if keys, and then this is pygame.k underscore left. This is the left arrow key. If you wanted to use the A key, then you would use A like that. Yeah, actually, I'll go with left arrow key because that's what I usually do, but you can use A or swap it however you want. And then I'm going to say, if this is the case, then player dot move underscore left. And how much do I want to move the player by? Because we have to pass the velocity. Well, this is going to be my player velocity, right? Okay, next I'm going to say if keys, and this is pygame.k underscore right. Then I'm going to say player dot move underscore right. Again, same thing. I'm going to move this by my player velocity. Now, it's important that before I do this, I set my player velocity to be 0. Now, the reason this is the case is because if I don't do this, what will happen is as soon as I move left, this is going to set my player velocity, right? Which you can see here, my X vel. It's going to set the X velocity. Now, once I set that, I'm going to continue moving in that direction until it gets set back to 0. So if you wanted to make it so when you press a key, you just continually move in that direction until you press a different key, then you could omit this. But in our case, we only want to move while you're holding down the key. So I'm going to say player.xvel equals 0. There's a lot of other ways to go about doing this, but I just wanted to stay consistent with our movement because of how we're going to do the gravity. So for now, just bear with me. We essentially set the velocity to 0. And then if we are moving left or right, so if we're pressing these keys, then we change the velocity to be, the negative player velocity or the positive player velocity based on the direction we're moving in. Okay, that's actually all we need for handling the movement. So let's put the handle movement function. Where are we going to put this? We're going to put this before we draw. So I'm going to say handle move. I'm going to pass my player. All right, now I need to make sure before I do this that I call my loop function, okay? And I pass my FPS. And the reason I need to call loop is because loop is what actually moves my player, right? If you look at loop, it's moving my player in the X velocity and Y velocity direction every single frame. So if I set the X velocity, well, then I continue moving. Again, if I set the Y velocity, I move in that direction, but that only works if we're continually calling this loop function. Okay, good. So we've made great progress so far. Let's see now if we can move our player or if I've made any mistakes, which are very likely. So let's run the code and let's see. Okay, so I'm going to hit my right arrow key. You can see I can move to the right and I can move to the left. Obviously, if I wanted to go up and down, I could implement that, but we want to have it jumping, which I will show you in a second, but we kind of need collision before we can do jumping. Very good. All is looking great so far. Now let's implement gravity so we kind of fall down. Then we can do kind of the sprite sheets. Then we can do the collision because the collision makes more sense, I guess, once we have the sprite sheets done. So let's implement gravity. Now, gravity is a little bit complicated because we want to have like kind of a realistic gravity, right? That actually implements some basic physics. What I mean by that is rather than just having a constant velocity, we want to actually have an acceleration for our gravity. So as many of you know, if you're in physics, gravity, the acceleration is negative 9.8 meters per second squared. I believe that's what the acceleration is. Anyway, in our game, we want to emulate something similar to that, where it feels like the longer you're falling, the faster you fall. You're not falling at a constant speed. That makes the game just feel like really, really unrealistic. So the first thing we need to do is pick some value that we want our gravity to be. And this is the acceleration of gravity. So keep that in mind. So for this, I'm going to make a variable in my player class because this is the only place we need it right now. I'm going to say this is equal to 1. So gravity is equal to 1. If you want gravity to be faster, obviously you increment this value, right? Make it larger. Okay. Now inside of loop, this is where we need to handle our gravity. So every single frame in our loop, we're going to increase the Y velocity by our gravity. However, how we know how much to increase the velocity by varies on how long we've been falling for. Again, I know this seems really weird, but we essentially need to keep track of how long we've been falling so that we know how quickly we should be increasing our velocity or how quick we should be accelerating downwards. So that means that I need to create a variable here called self.count. And given we should really call this something better, I'll call it fall count. And this will essentially tell us, okay, how long have we been in the air for? How long have we been falling? And we'll use this value to determine how much we increment our velocity by. So now I'm going to say my self.y underscore velocity. And I'm going to add to this the minimum of 1 or, and then I'm going to take my self.count, and this is my fall count, divided by the frames per second multiplied by the self.gravity. Now, this isn't truly what the acceleration would be, but this will give us like a kind of somewhat realistic looking gravity in the game. So just bear with me here. So what we're doing, we're taking our fall count, we're dividing it by FPS. The point of this is that if I want this value to be in seconds, then I need to take whatever my count is, which I'm going to increment every single loop. In fact, we'll do this right now. Plus equals 1. And I divide it by FPS. So if my FPS is 60, as soon as this is 60, then I've been falling for 1 second. I take that amount of time, I multiply it by my gravity, and then that tells me how much I'm going to increment my y velocity by. However, this is going to start out being really, really small, just like fractional decimal amounts. So just to make this a bit easier for us when we do our collision, I'm going to increment this by the minimum of 1 or this value. So every frame we're moving at least 1 pixel down, and it doesn't take us like a full second before we really start feeling any effect of gravity. Hopefully that makes a bit of sense. You guys are understanding me here, but just bear with me. I've experimented with these numbers quite a bit, so I think this should be fine. Okay, so now that we have this, what should happen when I just click run here is I should just start falling immediately on the screen. And obviously, until we have some platforms or collision, we can't really stop falling if we have gravity. But let's have a look and let's see how it works right now. Okay, so you can see that I fall. And notice, I'll do this again, that I start falling slowly and then it picks up the pace, right? So this is somewhat realistic to how gravity would actually work. And that's what I was trying to implement when I did this. Now that we have done that, it's time to move on and have some kind of sprites or images. I was going to do this later, but I realized that we can't really do the collision, which is going to be pixel perfect collision, until we have some kind of images. That's really what we need. We need our sprites. So what we need to do here first is examine what our sprites look like for our characters. Now remember, all these characters are pretty much the exact same. They just look different, but in terms of their movements, their animations, the number of images, they're identical. So whatever I show you for one of these is the same for all of them. Hence why we can just kind of swap them out. So when I go to mask dude here, let's zoom in. You can see that we have, for example, double jump, right? I just picked a random sprite sheet. Now this sheet has 6 different animations or 6 different frames, which represent what this guy's going to look like while he's kind of jumping or double jumping in the air. So what we need to do is we need to split this one image into the 6 individual images and then loop through those images at some frequency or some time so that we can show them on the screen and show an animation, right? We need to kind of manually do this. Now, some of these are single frames, like falling is just single frame. That's easy. Hit, okay? This is like, you know, the guy disappears for a second, kind of expands, goes back. You get the point. We want to loop through these animations. Idle, single frame. Actually, no, idle is not a single frame. It's a bunch of frames. This guy's arms are kind of wagging up and down. We have jump, a single frame, run, a bunch of frames, and then wall jump. Now, notice here with these images that they're in different directions, or let's say they're all kind of facing right. So another thing we're going to have to do is rotate this image to face left when our character is facing left. So that's another thing we have to handle, that not only do we just have to split these images up, we also have to get a rotated version of them so that we can show you moving in a different direction. Same with jumping, same with being idle, like whatever direction you're going, we need to show the image flipped in that direction. So not rotate, sorry, flip. That's what we're going to do. Okay, so let's do this. First thing I will do actually is I'll write the function that will flip our image. So I'm going to say flip sprites. This is going to take in a list of sprites. And I'm going to return pygame.transform.flip. And this is going to be sprite, true, false. Notice as it says here, this is indicating what directions you want to flip in. When I pass true, this means flip in the X direction. When I pass false, this means don't flip in the Y direction. If you wanted to flip both, you'd pass true twice, but we don't want to do that. So I have pygame.transform.flip sprite, and then this is going to be for sprite in sprites. Really, I could call this image, but you get the point. Okay, so we have flip. Now we're going to write a function, which is load sprite sheets. And should we call it sheet or sheets? I think sheets is fine. And what this is going to do is load all of the different sprite sheets for our character. So it's going to give us the sprite sheet for double jumping, for hitting, for falling. And then within our character, we can pick what sheet we want to be using and what animations we want to loop through. So I'm going to take in directory 1 and directory 2. And the reason I'm doing this is so that I can load other images that aren't just my characters, and this will be very dynamic. I also want to take in the desired width and height of my image, and if we need to load multiple directions. So I'm going to say direction equals false as a default parameter so that we only load like the left and the right side images, like we flip the images if you pass this equal to true. Okay, now the first thing we need to do is determine the path to the images we're going to be loading. So I'm going to say join assets dir1 dir2. Notice I can use join because I imported this from os.path, okay? Now I'm going to get all of the images in this directory. Now the way I do that is the following. I'm going to say images is equal to, and this is going to be f for f in list directory. Again, notice I can use that because I imported it here. We're going to list all of the things that are inside of this path directory. And then we're going to say if is file, and then this is going to be join path and f. So what this for loop is going to do here, this, I forget what you actually call this when you write a for loop in a list. Anyways, what this line is going to do here is load every single file, only file, that is inside of this directory. So again, we're just going to get every single one of these file names, and then once we have those file names, we can load that image, and we can then split that image up into the individual images that we want. Okay, so we have images. Now I'm going to say all sprites is equal to a dictionary, and what I'm going to do with this dictionary is have key value pairs where the key is the, let's say, animation style, and the value is all of the images in that animation. Okay, so I have all sprites. Now I'm going to say for image in images. And I'm going to say that my sprite sheet, so the individual sprite sheet I want to load here, is going to be equal to pygame.image.load, and then this is going to be join path and image, and then .convert alpha, which is essentially going to allow me to load a transparent background image. Okay, so we are loading the image, which is just one of the files that we found, right, from this path, and we just need to append the path to it, right? So whatever the path to the directory is, plus the image name. Okay, we're going to load that in. We're going to get the transparent background. Now that we have this, we need to get all of the sprites in this image. So I'm going to say sprites is equal to, and now this is going to be a list. Okay, so again, the process is load all of the different files. Okay, we have all the files. These are sprite sheets. Now we need to get all the individual images from the sprite sheet and load those. Okay, so I'm going to say for I in range, and then this is going to be sprite sheet.get underscore width, integer divided by the width of the image that we're loading. Now, width is going to be the width of an individual image inside of our animation or inside of our sprite sheet. So if I know this is, say, 32 pixels, I pass 32, and then it gives me a bunch of images that are 32 pixels wide. That's how I'm doing the loading. So that's why I took width and height here. Okay, now that we have that, we're going to say surface is equal to pygame.surface, and then this is going to be width, height. We're going to pass pygame.src alpha, which allows us to load, again, transparent images. And then I'm going to pass 32 here, which is the depth. Don't worry about that, but it's just what we need to load these images. And now we need to create a rectangle, which is going to tell us where in this image, again, image being the sprite sheet, that we want to take an individual image from and blit it onto this surface. I know this seems really weird, but what we're doing is we're going to create a surface that's the size of our desired individual animation frame. We're then going to grab that animation frame from our main image. We're going to draw it onto the surface, and then we're going to kind of export that surface. That's the way that we have to do this. So I'm going to say rectangle is equal to pygame.rect. And for the rect, this is the location on our original image that we want to grab this new frame from. So I'm going to say this is I multiplied by my width, and then 0, and then the width and the height of my image. Okay, now that I have that, I'm going to say surface.blit. Blit really means draw. And I'm going to draw my sprite sheet, but I'm going to draw this at 0, 0, and I'm only going to draw the portion of it, which is my rectangle. So notice this is my source, this is the destination, and this is the area of my source that I'm drawing. So in position 0, 0, which is the top left-hand corner of my new surface, I'm drawing my sprite sheet, but I'm only drawing the frame from my sprite sheet that I want. Okay, then I'm going to say sprites.append, and I'm going to append my surface, but I'm going to make my surface 2 times larger because that's what I want to do. I want this to be bigger than the default size. So I'm going to say pygame dot transform dot scale to x, and then I'm going to scale to x my surface. Okay. Again, I know this seems a bit complicated, but now we have essentially stripped out all of the individual frames. We've just scaled them up to be double their size. So if they're 32 by 32, we've made them 64 by 64. That's what scale to x does. And now we need to handle the directions. Okay, so now we need to say if direction, then all underscore sprites, and this is going to be image dot replace. It's going to be dot png. It's going to be an empty string plus underscore right is equal to our sprites. And then we're going to copy the same thing. Let's copy this and put it here. And now this is going to be underscore left is equal to, and this is going to be flip sprites. So what we're saying here is if you want a multi-directional animation, then we need to add 2 keys to our dictionary here for every single one of our animations. So for falling, for hit, for idle, we need a left and a right side. So the right side is the one that we already have. So we're going to say, okay, all sprites at, and then we're just going to strip off the .png from whatever the name of our base image was. So that's going to give us run, jump, idle, hit, whatever the name of our files. And then we're going to append underscore right or underscore left. Now for underscore right, that's our basic sprites. For underscore left, we need to flip all of those sprites, and we already wrote the function that did that. Now otherwise, then what we'll do is say all underscore sprites at image.replace .png with an empty string. This just removes the .png, and then it's going to be equal to sprites. Okay, then we can return all of our sprites. All right, probably one of the most complicated aspects of the code that we need to write. So don't worry, we are done now with loading images. At least, well, we'll have to load our block, but that's going to be a lot easier than loading our sprite sheets. So this now will load a sprite sheet for us. Now that we've loaded our sprite sheet, we actually want to start using this. So inside of player, we are going to grab our images. So I'm going to say my sprites is equal to, and this is going to be load sprite sheets. And now I need to pass what I want to load. So now I need to pass the main character directory. And actually this is main characters. Okay, so have a look here. So inside of assets, right? Yes, so we're joining assets with dir1 and dir2. So the first directory I pass is main characters. And then I pass the second directory, which is the name of the character I want to load. So mask dude, ninja frog, pinkman, or virtual guy. You can pick whatever one you want. I'm going to go with mask dude for now. Now for width and height, the width and the height of this is going to be 32. So make sure you do this 32, 32. And then you pass true because we want a multi-directional sprite. So both left and right side animations. That's what we want. Okay. Now that we have that, we are going to change our draw here so that we're drawing our sprite. Now for now, we're just going to draw like one simple sprite just so you see how it looks on the screen. Then I'll go through animating the sprite and showing you how that works. Okay, so rather than pygame.draw.rect, I'm going to say self.sprite is equal to, and then this is going to be self.sprites at idle. Now, idle is one of the name of our animations, right? So if we go here, you can see we have idle, jump, etc. So I'm accessing the key from my dictionary, and then I'm going to access the first frame of this key, which is 0, because every single key is a whole like sprite sheet, right? So now that I have my sprite, I'm going to say win.blit, and then this is going to be self.sprite, and I'm going to blit this at self.rect.x and self.rect.y, which is the position on the screen. And then if we want, we can just turn off the gravity for right now so that we can kind of see it on the screen and it doesn't just disappear. Okay, let's try this out. Let's just make sure it actually loaded correctly. So let me run this, and we got an error. Okay, so let me see what error we got here. Run this again. It said key error idle. Okay, so the issue here is that since we load a directional sprite, we need to reference either idle right or idle left. So we can actually do this by saying idle underscore plus self.direction. And then so long as we set the direction, which we did here, to left, this should work. So now it'll change based on if we're going left or right. So actually you'll see that it should swap as we change directions. Okay, let's try this now. All right, so now we have this guy facing left. If I go right, he turns right, left, right. Perfect. Now we want to see him animated. So as I was saying, let's get into the animation. Now, this is actually going to be pretty easy because we've already loaded in all of the frames that we need. So I know that we don't have a ton to show right now, but a lot of the hard stuff is done for this video. So just making you aware that all this time has not gone to waste. What we need to do is we need to come up with something that has a way to kind of update our sprite or update what we're showing on the screen. So I'm going to write a function here called update sprite. And I'm going to take in self, and I'm going to say sprite sheet is equal to idle. Now, this is the default sprite sheet. If we're not moving, if we're not jumping, if we're not falling, if we're not being attacked, we use idle. However, if we are running or we're doing something else, then we use the other sprite sheet. So now I'm going to say if my self.x velocity does not equal 0, then my sprite sheet is going to be equal to run. So if I have some velocity in the x direction, then I'm running, right? So then I want to change this to the run sprite sheet. So now I'm going to say my sprite sheet name is equal to, and this is going to be my sprite sheet plus, and then underscore, and then plus the self dot direction. Perfect. So now we just change the main sprite sheet name. So idle, run, jump, whatever. We add the direction to it, and this tells us, what exact sprite sheet we want. Okay, now that we have that, what we're going to do is say the sprites that we could be using for this animation is equal to self.sprites, and this is in all capitals, at the sprite sheet name. All right, now that we've done that, we need to essentially iterate through these sprites and every few seconds change the sprite that we're showing so that it looks like we're animating. So we need to add a variable here that is going to account for the amount of delay between changing sprites. So I'm going to call this the animation delay. I'm going to make this equal to 5. Okay. Now I'm going to come here and I'm going to say that my sprite index, which is essentially the sprite that I want to be using here, is equal to my self.animation count, which we're going to increment in a second, integer divided by my self.animation delay, modulus by the length of the sprites that I'm using. Now let's just put some parentheses here for order of operations. And let me explain what we're doing. So we have an animation delay. That's every 5 frames. So every 5 frames, we want to show a different sprite in whatever animation we're using. So if we're running left, if we're idle, whatever, it doesn't matter. We want to show a different one. So we take the animation count, we divide it by 5, and then we mod whatever the length of our sprites is. So if we have 5 sprites, then when we're on, say, animation count 10, we're showing the second sprite, right? You get the idea. So this is dynamic. This will now work for any single sprite. So hopefully you guys understand how this animation count is kind of working, but we're just trying to pick a new index every animation frames from our sprites, but we want this to be dynamic. So we're using the length of the sprites. And again, it's dynamic. It will work for any single sprite sheet we have. Now we need to select our sprites. We say self.sprite is equal to the sprites that we have access to at the sprite index. Then we update our animation count by 1. Now what we can do is remove this here from draw, and we just need to now call the self.update sprite from our loop. Okay, so now that we've done that, we'll call this, we'll update our sprite every single frame, and then we'll draw that updated sprite on the screen. Okay, let's run it and let's see what we get. Notice we have idle. Notice I can run to the right and I can run to the left. Now, if you think this is too slow, and some of you may argue that it is, then you just make this number smaller. So make this 3. Okay, and now it looks like we're running a little bit faster. So it's completely up to you how you want to animate this. I'll do 2 for now, and let's see if this looks better. So actually, I think 3 was a pretty kind of happy medium here, so let's go back to 3. Again, you guys can change this. It's up to you how you want it to look. Okay, now that we have that, we're almost ready to start doing collision. However, we need to introduce something known as a mask. So I'm going to make another method here. I'm going to say define update. Now, what we need to do here is essentially update the rectangle that bounds our character based on the sprite that we're showing. So there's different like kind of sizes to the sprites, right? Some are a little bit taller, some are a little pushed to the left or pushed to the right. And the rectangle that we have, we want to be essentially the same as the sprite that we have. Again, I know this seems a bit weird, but we're going to do this. We're going to say self.rect is equal to self dot, and then this is going to be sprite dot get underscore rect. And we're going to say that the top left of this rectangle is equal to the self dot rect dot x and the self dot rect dot y. Now, pretty much what's going to happen here is depending on what sprite image we have, if it's slightly smaller, slightly bigger, whatever, we're going to constantly adjust the rectangle. Specifically, we're going to adjust the width and the height of it, but we're going to use the same X and Y position that we've had for this rectangle. If you don't understand that, that's fine. It's not a massive deal. This line is not crazy important, but it's just trying to make sure that the rectangle we're using to kind of bound our character is constantly adjusted based on the sprite that we're using. Now, what's more important is this line, which is updating the mask. We're going to say self.mask is equal to pygame.mask.fromSurface, and this is going to be self.sprite. Now, let me quickly explain this. A mask is essentially a mapping of all of the pixels that exist in the sprite. So whenever we draw something on the screen, we're really drawing a rectangle, right? But the rectangle may not have non-transparent pixels, right? So only part of the rectangle is actually filled in, hence why we get kind of a circular image, a dynamic image, whatever. So what this mask tells us is where there's actually images, or where there's actually pixels, sorry. And this mask allows us to perform pixel perfect collision because we can overlap it with another mask and make sure that we only say two objects collide if pixels are colliding, not if the rectangular box is colliding. If we did rectangular collision, then it constantly looks like we're hitting something even when we're not, because the rectangle for our character is larger than where all of the pixels for our character are. You've probably seen this in a lot of games before, but what the mask does is solve that problem for us and allow us to do this kind of pixel perfect collision. It's very important, though, that you call this mask. If you don't do that, this collision is not going to work properly. It needs to be mask because the sprite that we inherited from here uses this rectangle and uses this mask property when it does the collision. All right, so now that we've done this, I just need to call this function. So I'm going to go here and say self.update. And now we're done with most of what we need for the player. So what we want to do now is we want to start adding blocks onto the screen and then letting a player fall, collide with those blocks, and then be able to jump. Because obviously we can't really jump until we have something to jump off of. Otherwise, jumping in thin air doesn't make a ton of sense. All right, so let's create another class here. And this class I'm going to call object. And this will be a base class that we use for essentially all of our objects, just so that the collision will be uniform across all of them. So again, we're going to inherit from the sprite class from Pygame, and we're going to define our initialization. So define init, we're going to take in self, x, y, width, and height, and name, which for now is going to be equal to none, but could be equal to something. We're then going to say super dot underscore underscore init, which will initialize the superclass, which is this one right here. Now that reminds me, we need this as well in our constructor for player. So let's put that in player. Okay. Now we need to define our rectangle. So we're going to say self.rectangle is equal to pygame.rect. And then this is going to be x, y, width, and height. We're going to say self.image is equal to pygame.surface, and then this is going to be width, height, and then we're going to say pygame.source alpha like that. If we spell pygame correctly, again, this just supports transparent images for us. My apologies. And then we're going to say self.width equals width, self.height is equal to height, and self.name is equal to name. We're then going to say define draw. I'm going to say self and window like this. And then we're going to say win.blit. And this is going to be self.image. And then we're going to blit this at the self.rect.x and the self.rect.y. Okay, I know I went fast. Essentially, this is just a base class. We're not actually going to instantiate this, but this just defines all of the properties that we need for a valid sprite. So we have our rectangle, we have our image, we are drawing the image, and then in a class that we're about to use, we're going to inherit from this, and it will just save us from rewriting a bunch of functionality that we don't need. So the idea here is that all we do is modify this image. When we change the image, now the draw function will automatically draw it accurately on the screen for us. And all these other properties we're just saving in case we need them from our child class. So I'm going to make a class now called block. This is going to inherit from object. Now we're going to say define init. We're going to take in self, x, y, and the size of our block. Now, since the block is a square, we just need one dimension, not two, right? Okay, we're going to say super dot underscore underscore init. And we're going to pass x, y, size, size. So notice this constructor requires 4 arguments, so we have to pass 4 here. We just duplicate size because it's the same for the width and the height. Then we're going to say block is equal to load block, which is going to be a function that we write in a second that will take a size. We're then going to say self.image.blit. Imagine that this is going to give us an image, okay, which it will in a second when we write it. We're going to blit the block at position 0, 0. And then we're going to say the self.mask is equal to pygame.mask.fromSurface. We're going to take our self.image, and there you go. We have our mask, which we need for collision. Okay. Again, I know this is a little confusing. It'll make more sense in a second, but we're using this object, which now has this draw function built in for us. It also defines the rect. It defines the width and the height and all of that stuff. Here, what we do is we get the image that we need, which we're going to write this in 1 second. Then we blit this image to our image, which is a Pygame surface. And then we say self.mask is equal to pygame.mask.fromSurface self.image. We also could just say self.image is equal to the block, but let's do it this way for now. Okay, so let's now write our get block function, which I'm going to do beneath our get sprite sheet or load sprite sheet. So I'm going to say get block, and I'm going to take in a size. Now, what I need to do here is essentially find the block that I want in my train folder. So I'm going to say path is equal to join assets, and then this is going to be terrain like so, and then we're going to use the terrain.png file. So if I go here, you can see that we have terrain, and then what we want to do is load this block, which I'll be showing you how to load in 1 second. Okay. Now that we have done that, now that we have our path, we're going to say the image is equal to pygame.image.load, and we're going to say path, again, .convert alpha so that we get a transparent background. We don't really need it for this one, but just in case later we load something that does have transparency, we will. And then we're going to say surface is equal to pygame.surface, and for the surface, we're going to pass size, which is the width and the height of our surface. We're going to pass pygame.sourceAlpha with a depth, of 32. We're going to say rectangle is equal to pygame.rect, and then this is going to be 96, 0, size. Now, let me slow down for 1 second. If we go to terrain, we can see that we want to load this guy right here. Now, I've already done the math. This image starts 96 pixels from the top of the screen. So that's the reason I'm putting 96 there, because I want to start at 96. So 96, 0 is my position. And then I want to load the size of this, which I think is going to be either 96 or 64 or something along those lines. Anyways, if I wanted to load, say, this terrain image, then I would still have 96, but my Y position would be different. In fact, the Y position would probably be a little bit less than 96. It might be 80. It might be 85. I'd have to experiment with it to see exactly where this image starts. But I just want you to understand that what I'm passing here when I say something like 96, 0, I'm passing the position that I want to load the image from the image, right? So I'm picking out a part of this image, and this is 96, 0. That's why I'm picking it right here. Hopefully, you guys understand that, but if you want to load a different terrain image, then you have to adjust these to be the starting position, the top left-hand corner of whatever image it is you want to load here. And I was going to say we could load a different one, but I don't want to waste time guessing which one it is, so you guys can mess with that if you want, but let's just load this top one, which I already know works. Okay, now that we have that, we're going to say surface.blit, and we're going to blit the image. And again, we're going to blit it at 0, 0. But we're only going to blit the area of it, which is represented by the rectangle. Then we're going to return pygame.transform.scale to x surface. Okay, so we've passed what size we want our block to be. Then we create an image that is of that size. Okay, we then say rectangle is equal to 96, 0, size, right? And then we blit this image onto our surface, which will be the image that we return. And we return this scaled up by 2 times. So it just doubles the size that we pass here. You don't have to scale it if you don't want, but I want it to be larger, so I am scaling it. Now, I understand, again, it's a bit confusing. This size is going to be the dimension of this block. So you want to pass whatever the size from this sprite sheet is that you want to get. In our case, I think it's going to be 64 or something along those lines. So that's what size will be. You guys can mess around with this, but really what you're going to be changing is these 2 values and the size. That's what you're going to change when you want to load a different image for your block. Okay, so now for block, we have get block or load block. Did I call it load block or get block? I called it get block. Okay, so let's change this to be get block. All right, so we now have our block. Let's create a block. Let's draw a block on the screen, and let's do some collision with our blocks. Okay, so let's go here to main, and let's say blocks is equal to, and let's just start by creating a single block. So for our block, let's just put it kind of randomly on the screen for now. Where do I want to put this? Let's go with something like, actually, I'm going to create a variable first. I'm going to say block size. Let's put this at 0, height minus the block underscore size. Block size is going to be equal to 96, okay? And then for the size, we're going to pass block size. Okay, so the size of our block is actually 96. I lied. It is not 64. It's going to be 96. So we're going to create a block. It's going to be positioned at 0, height minus block size, which is going to put it at the bottom of the screen. And then the size is this. Now we need to draw our blocks. So I'm going to pass blocks to my draw function. Okay, and I'm going to go here. And actually, let's call this objects. And we're going to say for object or for obj in objects, if we could type this correctly, obj.draw. I'm struggling here with the typing, and we will draw this on the window. Okay, so we have our block now. Let's quickly look at this again, right? We load our image. Okay, we get our block. We have our size. Now we create the block down here, and then we put it on the screen. Let's run it, and let's see if we get a block. And of course, we got an error. What does it say here? I need to run this again. Take 0 positional arguments, but 1 was given. Okay, so let's go to our player class here. And we can see update. I forgot to add the self parameter. So let's add that in, and that should fix it. Okay, so now you can see that we have a block. So now what we can do is create a whole floor of blocks if we want to do that. And then we'll implement gravity and then collision with the block so that you can see that you can land on the block and we can jump off of the block. All right, so let's make a whole floor. So to make a floor, we can do this. We can say floor is equal to, we're going to say block. It's going to be I times block size. It's going to be height minus block size, for I in range. And then I'm going to say negative width times 2. And we're going to divide this by the block size and by the block size. Okay, then for my blocks, let's actually just replace this, and instead we'll just pass floor. Okay, what I've done here with this for loop is I've said I want to create blocks that go kind of to the left and to the right of the screen. So I don't want to just fill the current screen because we're going to have a scrolling background in a second, which we'll implement in a minute. Anyways, I want to have some kind of going to the left and some going to the right. So I'm taking my negative width over the block size, which is how many blocks I want to the left side of the screen. And then I'm taking my width times 2, and I'm integer dividing that by the block size again. That's how many blocks I want to the right of the screen. Then I'm taking I'm multiplying it by my block size, which is telling me the x coordinate position that I want my block to be at. And then this is always going to be the same because I want it to be at kind of the bottom of the screen. And then for my block size, well, I want that to always be the same. Okay, so let's run this now and see what we get. And now we get a bunch of blocks. So now that we have these blocks, let's make it so we can collide with the blocks. And so we have gravity and we actually fall onto those blocks. So the collision. All right, collision is a little complicated, but let's write it and let's see how we can get it going here. So inside of handle move is where we're going to handle our collision, which means we need to have a list of objects that we can potentially be colliding with. Now, we are going to write a function here called handle vertical collision, because we need to handle the vertical and horizontal collision differently. For now, we'll just start with vertical. Now we're going to take in player, objects, and the displacement in Y that we just moved. Now we're going to have collided underscore objects is equal to a list. And we're going to say for object in objects. These are all the objects we could be colliding with. And we're going to say if Pygame dot Sprite dot collide mask, and then we're going to pass our player and our object. Now remember I told you collision was going to be simple? Well, there you go. This is all you need to do to determine if two objects are colliding. The reason we can do this is because our objects we've inherited from the Sprite class, and on them we have a mask. So we're going to use this mask property as well as the rectangle property when we collide with the mask. So I pass my player, I pass my object, and this will tell me if I am colliding with my object. Perfect. Now, if I am, I'm going to do some stuff differently depending on what direction I'm colliding in. So if I'm hitting the top of the object, it's going to be different than if I'm hitting the bottom. So we need to handle that here. So I'm going to say if my displacement y is greater than 0, really this should be velocity, but that's fine. Then what I'm going to do is place my character on top of the object it collided with, so I'm no longer colliding with it. Now, what this is saying is if I'm moving down on the screen. So if I'm moving down, then that would mean I was colliding with the top of this object. So if I am, I'm going to take the bottom of my player rectangle, which is my player's feet, essentially, and I'm going to make it equal to the top of the object I'm colliding with. This is another advantage of using rectangles. You can use this kind of bottom and top property and avoid having to do, add the height and all that kind of stuff. So that's what I'm going to do. Now, otherwise, I'm going to say if my displacement y is less than 0, and I suppose this can be an elif, then what I will do is say my player.rect.top is equal to the obj.rect.bottom, because if I'm moving up, which means I have a negative velocity, then I am hitting the bottom of an object, so I need to make my top be equal to the bottom. Okay, this just makes it so you don't stay inside of the object, you go outside of it, and it looks like you collided, but you didn't go through the object. Now, one thing we also need to do here is we need to call the method player.landed and player.hitHead, which I've not yet created. And we're going to write these to handle what happens when we land on a block and when we hit our head on a block. Okay, then we're going to say collided objects dot append, and we're going to append our object, and we're going to return our collided objects, just so that we know what objects we collided with, so that we can check if we collided with like fire or a certain special object or something like that. Okay, so that's handle vertical collision. Now we need to write the landed and hit head method. So let's go to player and let's do this. So I'm going to say, let's do it here. Landed self. Now, what do we do if we landed? Well, if we just landed, then we need to reset our gravity or our fall counter. So we're going to say self.fall count is equal to 0. So that way we stop adding gravity, right? Okay, what else do we need to do if we landed? We need to say that our y velocity is equal to 0. If we landed on a block, stop moving us down. And I'll add this in now. We're going to say our self.jump count is equal to 0. We're going to do something with jumping that involves double jumping, so we'll have a jump counter. I'll just put this here now, and then we'll use it later. Okay, so that's if we landed. Otherwise, I'm going to say define hit head. For self, I'm going to say self.count equals 0, but if we hit our head, I want to reverse our velocity so that now we move down because we're moving up, right? So I'm going to multiply my velocity by -1 so that when I hit my head, I kind of bounce off the block and go downwards. That's what's going to look most natural. Okay, so that's all we need for right now for hitting the head. Now we can add our gravity back. And when we add our gravity back, what's going to happen is we'll fall, we'll hit the block, it'll move us to the top of the block, and then we should just be able to move on top of the block. Let's see if that's going to work, though. Although, it's not going to work if we don't add the function call. So let's add the function call here. In handle move, we're going to say handle vertical collision. We'll pass the player, the objects, and the player.y velocity. And the y velocity is essentially how much we just moved, right? Okay, very good. Now let's make sure handle move, we need to pass our floor. So let's do that. All right, let's run the code. Let's see what we get. And boom, look, we land on a block and we can now run on top of the block. And everything is looking very good to me. Okay, so that's pretty good. Now that we're on top of a block, we can jump, and then we can deal with hitting blocks, horizontally, right? So that we can't like run into a block, and we'll also make the background scroll, and then we'll be pretty good. We'll have a lot of this tutorial finished. I wanted to make us jump. Yes, let's make it jump. Okay, so let's go to our player, and let's create a variable here, self.jump_count is equal to 0. Now, based on the way we've coded this, jumping is actually quite easy. I can say define jump self. And when we jump, all we're going to do is say self.y_velocity is equal to the negative of self.gravity multiplied by whatever factor you want in terms of the speed of your jump. So I'm going to multiply gravity by 8. The reason I'm doing this negative is so that I jump up in the air, right? So now that I've done this, what will happen is as soon as I hit the jump key, I'll jump up into the air. It's pretty straightforward. And the reason that's going to happen is because my y velocity will change. And what will bring me down is the fact that inside of my loop, if I go to where loop is, I'm constantly applying downward gravity. So what I'm doing is changing my velocity to go upwards, and then I'm letting gravity take me down. So that's kind of the benefit of how we've coded this. Jumping is very easy. Now I'm also going to reset my animation count to 0. I'm going to say my jump count plus equals 1. I'm going to say if the self.jump_count is equal to 1, this means that I'm double jumping. So if the jump count's equal to 1, when I hit jump, that means it's just going to be equal to 2 now. Actually, let me take this, sorry, and put this down here. Then I will say self.count is equal to 0. Yeah, I think, does that make sense? No, I want to do it this way. Sorry. Okay, so what I'm trying to do here is make it so that as soon as I jump, I essentially get rid of any gravity I've already obtained. So let's say I was like falling and then I landed and then I jumped. There would be some gravity on me keeping me on the ground. So I want to remove that gravity so that when I jump up, it's not in the factor. It's not taken into account. And then I'll start applying the gravity after I've jumped. Hopefully that makes a bit of sense, but this should say fall count. So as soon as I jump, I'm resetting the fall count to be equal to 0 so that any gravity I've accumulated, I'm removing. But I'm only doing that if this is the first jump I'm making, because for the second jump, I want you to have to time it based on like when you're jumping, right? So if you jump a second time, close to when you jumped the first time, you will jump higher than if you jumped at like the peak of your jump when your gravity would be the highest. Okay, I don't know if that makes sense, but just follow along here. I messed with this before. This works. Trust me. All right, so we have jumping now. I think that's all we really need for jumping. Yeah, that seems good to me. So now if we want to jump, let's make it so when we hit space, we jump. So we can do that inside of handle move. Actually, I'm not going to do it in handle move. I'm going to do it here in the event loop. And the reason for this is that if I do it in handle move, what's going to happen is if I press the jump key and I hold the jump key down, I'm going to keep jumping a bunch of times. I don't want to do that. I just want to jump once when I hit the key, and then I have to release the key and press it again to jump. This tells me if I'm holding down the key. What I'm going to do in here tells me if I released the key. Yeah, you'll see. But yeah, this is how I do it. So I'm going to say if event.type is equal to pygame.key down. Then I'm going to say if event.key is equal to pygame.k_space, and my player.jump count is less than 2, because I'm going to allow double jumping, right? So I'll have 2 jumps. Then I'm going to say player dot jump. Okay. That should be all we need for jumping. So let's try it out, and let's see if this works. And I can jump. And notice I can kind of run and jump at the same time. Now, what I'll do now is add like falling and jumping animations, because obviously it looks kind of weird right now when I'm jumping. But there you go. We can jump. Nice. Okay, so let's add the animations now. So if we go to update sprite, all we need to do here is we need to say if self dot, and actually I need to refer to my cheat sheet here because this is a bit more complicated than I thought. Okay, I'm going to say if self.y underscore velocity does not equal 0. Then what I will do is say if self.jump count equals 1, then I'm going to say my sprite sheet is equal to jump. I'm going to say elif self.jump count equals 2, then my sprite sheet is equal to double jump. Now this is actually going to be if my velocity is less than 0, which means I'm moving up. Now the next one that I want to add is I want to say if, and actually these are all going to be elifs. Well, not that one, but this one. I'm going to say elif my self.y underscore vel is greater than 0. This means I'm moving down. Then my sprite sheet should be equal to fall. Okay. So this is handling regular jump and double jump, and this is telling me if I am falling. Let's try it now, and let's see what happens when I jump. Okay, so it's kind of glitching a little bit. The reason this is happening, I believe, is because we are applying gravity even while we're on the ground. So my y velocity is always greater than 0, and then stops being greater than 0, then it's greater than 0 again. So I will show you how to fix this. All right, so actually the way that I'm going to fix this is a bit of a hack, but it's going to be good. It'll work here. So I'm actually going to say if my self.y velocity is greater than self.gravity times 2. Now, the reason I'm going to do this for fall is so that I don't immediately start glitching into this fall state when I have a really low amount of gravity being applied to me when I've gone off the block and then I've fallen down to the block. So let me show you what I mean by just kind of running the code here. So you can see that what happens is when I hit the block, when I collide with it, it's going to reset my gravity count, and then I'm going to kind of spawn to the top of the block. So when I'm on the top of the block, I'm going to be slowly falling down to the block, then I'm going to hit the block. When I hit the block, it's going to do the same thing. It's going to bring me to the top, reset my gravity count. So what was happening before is that we would go to the top of the block, and then our gravity would increase a tiny bit, right? It would increase to be 1 pixel per second or something along those lines, which would mean we were falling. So then we were falling, we hit the block, and then it reset it. So it kept glitching between the two states. So what I've done is just made it so we have to have a significant amount of gravity before it starts showing that fall state. So now it doesn't look glitchy on the screen as I'm jumping around. And you can see that what actually happens is when I jump and I get to the peak of my jump, you can see that it starts the falling state because now my velocity has changed directions, right? Now I'm going down. Okay, so now we have jumping. Now we have running around and colliding with blocks. Done quite a bit, actually. The next thing I want to do is make it so that objects move on the screen. Then we will do our horizontal collision, and then we will pretty much be done after I add kind of that like fire state, right? Or that, let's call it a trap, something like that. Okay, so we want to do scrolling background. Scrolling background is actually fairly easy. The way that we do a scrolling background is we simply offset every single thing that we're drawing on the screen by a certain amount. So any object that we have, we don't change its position at all. We just change how we're drawing it on the screen. So it doesn't affect any of our collision. All it affects is what's seen, right? So what's happening in the background is we may be colliding at a really far position to the right, but we're showing the position currently on the screen. You see what I mean? But what this involves is having some offset x, which I'm going to say is equal to 0. Now, the way that I want to have it, and I'll just illustrate here, is that when I'm on the screen, I only start scrolling the background when I get close to the edge. So like here, right, it would start scrolling. Whereas if I'm in the middle and I'm kind of moving like this, I don't want it to scroll the background until I get to the edge. Oh, also notice you can double jump here. I kind of forgot to mention that part. So I'm going to implement that where essentially once we reach a certain boundary, then the screen will start scrolling. All right, so how do we do this? Well, we can do it just directly inside of our loop here. And we're going to do it here. We're going to say if the player dot rect dot x minus the offset x plus the player dot rect dot width. And actually, now that I think of this, we're just going to do this. We're going to say if the player dot rect dot right, which will account for the width, minus the offset x is greater than or equal to the width minus a variable that I'm going to write in a second, which is scroll area width, and the player dot x underscore velocity is greater than 0, then we're going to say offset underscore x, and this is going to be plus equals the player dot x velocity. All right, let me just write this variable, then I'll explain how this works because we also have to do the other side. So I'm going to say scroll area width is equal to 200. What that means is that when I get to 200 pixels on the left or 200 pixels on the right of the screen, I start scrolling. Okay, so here what I'm doing is I'm checking if I am moving to the right. That's what this checks. If my x velocity is greater than 0, that means I'm moving to the right. And this is checking if my character is right on the screen, like if it's crossed a specific boundary. So I take whatever the right position of my player is, which could be very far off the screen. I subtract whatever offset we currently have. So if we're offsetting everything by 100 pixels, for example, I subtract that. So I know where I'm actually showing the character on the screen. And I say if that's greater than the width minus the scroll area width, which means I'm at, say, 700 pixels, something like that, on the right side of the screen, then I'm going to offset the screen by whatever the velocity was that my player just moved to the right. So that will make it look like I'm scrolling. Now we can say or and do the exact same thing for the left side. So I'm going to say if player dot rect dot left, and this is actually going to be plus the offset. I got to check if it's plus or if it's minus. No, it's going to be minus again. Minus the offset x is less than or equal to the scroll area width. And my player dot x underscore vel is less than 0, then I want to do this. Now let's move this down on the screen a bit. And I'm just going to add some parentheses so that my condition is correct here. Okay, so I think that should be good. Again, I'm checking to the left and to the right side. If I'm moving to the left, I want to check if I'm at that boundary. If I'm checking to the right, or if I'm moving to the right, sorry, I want to check if I'm at that boundary. And then I increment my offset x. Now, all I have to do to account for this is add an offset x to my draw function and draw every single object offset by this x. So I'm going to go here and say offset underscore x. And now, just to all of my draw functions, I'm going to pass offset x, offset underscore x. And I'm going to go to all my draw functions, and I'm going to add this. Offset x. And what I'm going to do is just subtract the offset x from the x position I'm drawing everything at. So I'm going to say minus offset x, and we'll take in the offset underscore x. Okay, now the reason this works, if I move to the left, my offset x is going to be negative, which means everything is going to push to the right side because we're adding to the position for it. If I move to the left side, or sorry, if I move to the right side, the offset x is going to be positive, which means everything is going to move to the left, so it has a scrolling background effect. Let's just run it though and see if it works, then I can fix it if it doesn't. Okay, so as I start running here, you can see that now the floor is going to start going with me once I reach this boundary. However, on this side, right, like kind of when I'm in the middle, it's not doing anything. I have to get to a certain boundary, which is kind of invisible on the screen, and then it starts scrolling with me, which is what I wanted to do. And then notice if I jump here, boom, I fall off the platform. Let's do collision with blocks in the horizontal direction. So to do that, I'm just going to add a block here. So I'm actually going to make a list. I'm going to say objects is equal to asterisk floor. Now, if you've ever seen like kind of ... in JavaScript, that's what this does in Python. It just essentially breaks this floor into all its individual elements and passes them inside of this list. So imagine it, if me just writing this here, that's what it's doing. And then I'm going to pass another block. And for this block, I'm going to place this at let's do 0. And then for the y, this is going to be the height of the screen minus the block size times 2. Now, the reason I'm multiplying this by 2 is so that I get it a bit higher on the screen, so that we can kind of run into it horizontally. And then I'm going to pass my block size. So I'll just see now, I want to go and rather than drawing my floor, I want to pass objects. And same here with handle move, I want to pass objects. So let me run this. So now you can see that I have that block there, right? Now notice that when I hit the block, I kind of go to the top of it. And the reason I go to the top of the block is because right now I'm only handling my vertical collision. So when I hit the block, I have a little bit of gravity, because remember, there's always some gravity on me when I'm on the floor. And so it thinks that I've hit the top of the block, so it spawns me on the top of the block. So we need to make it now so that when you hit the block in the horizontal direction, it kind of pops you off of it so that it doesn't think you're hitting the top of the block or the bottom of the block alternatively, which you'll see in a second. And in fact, let me add one more block to show you hitting our head on the block. So let's add another block. Let's make this at, say, block size multiplied by 3. And then for the height, let's do times 4. Okay, now we have another block. Let's see where this guy is. Now I can show you that I can hit my head on the block, right? And I can't kind of go above it. Okay, anyways, we have that. Let's do our horizontal collision. So the horizontal collision is a bit weird to implement. The idea behind this is that since we're using our Sprite collide mask, we want to make sure that if we collide with a block horizontally, we move ourselves off of that block so that it doesn't think that we're colliding with it in the vertical direction. Now, you just saw that happen. We hit the block. It thought that we were hitting it like the top of the block, so it put us on the top of the block because that's what this line does right here. So in our horizontal collision, we essentially need to check, okay, by moving in this direction, are you going to hit the block? If you are going to hit the block, we want to prevent you from moving in that direction so that you don't hit it, collide with it, and then we like spawn to the top of it. So let me write it, and I'll explain to you how it works, but it's just very important that we check the horizontal collision first. Then, once we check that, we check the vertical collision, because we only want to check vertical collision if we are not colliding with a block horizontally, or if we haven't already handled, or if we have already handled the horizontal collision. Again, the idea is we don't want to be thinking that we're hitting the block on the top when really we hit it on the left or the right side. So we got to check that first. So I'm going to make a function. I'm going to say define collide. I'm going to take player, objects, a displacement x, like that. Now I'm going to say player.move, and I'm going to move my player in the displacement x direction and 0 in the y direction. The reason I'm doing this is I want to check if with the current velocity that my player has, now the reason I'm doing this is I want to check if my player were to move to the right or if they were to move to the left, would they hit a block? That's what I'm checking essentially by moving the player preemptively. So now what I need to do is say player.update. Now the reason I need to call .update, and let's go here to .update, is because I need to update the rectangle in the mask before I check for collision. So again, what I'm doing is I'm preemptively moving my player to where they would be moving if they were going left or right. I'm updating their mask and their rectangle. And then I'm going to say for object in objects if pygame.sprite.collide mask. And then I'm passing my player and my object. So this is why I needed to update my mask and my rectangle. So I move my player, I update it, and then using that updated mask, I check would I be colliding with an object. Now I'm going to say collided object is equal to none. I've got to spell collided correctly. If I am, then I'm going to say collided, and this is just going to be object, is equal to obj. Then I'm going to break. Okay. Then I'm going to say player.move, and I'm going to move them back. And then I'm going to say player.update. Okay. And then I'm going to return the collided object. Okay. So what I'm doing, right? I'm moving my player. I'm updating the mask. I'm checking if they would collide with something if they were to move in that direction. Then if they did, okay, I get that collide object. It doesn't matter if they do or they don't. After I check this collision, I have to move them back to where they originally were. So I have to reverse the movement and then update the mask again. Then I return collided object. Okay. Again, moving, checking if we hit anything. Either way, moving back to where we were before. This is preemptively checking before we allow them to move into a block. All right, now what we need to do is use this function to allow us to move left or right, or to disallow us from moving left or right. So I'm going to say collide underscore left is equal to collide player objects, and then negative player vel. Then I'm going to say collide underscore right is equal to collide player objects, and then player vel. And then I'm going to say and not collide left and not collide right. Again, what we're doing here is we're checking if we should be able to move left or if we should be able to move right based on our current position. That's why I make that preemptive movement. And then here, I only let you make the movement if that movement does not cause you moving into a block or colliding with one. Now that we have that, that should actually handle our horizontal collision. That's actually all we need. All right, so let me run this code and let's see. So I'm here. Okay, obviously that's still working. And you can see that I can't go through the block. Now let's go here. And actually, I'm getting a bit of a bug on the right side. Okay, so that time it worked, but it's a little bit glitchy. And I have a feeling it has to do with the animation count of me running, because it's only sometimes when I'm running and I hit the block that it spawns me up here. So I'm just going to do another little hack here. And I'm just going to multiply this by 2, both of them here. The reason for this being that I'll just make it so there's a little bit of space between the block. And that way me changing the sprite isn't going to affect if I collide with the object or not. Because remember, the sprites kind of shift to the left or to the right a little bit. So just by adding this multiplied by 2, it should make it so that I'm never going to be colliding left or right. It will make it so there's a bit of space. See how there's a bit of space between the block now. But that's okay, because now I'm never going to have that collision bug where it's going to spawn me to the top. And really, you could probably just add 1 or 2 pixels, but you can see that that kind of fixed it right there. Okay, so now we have collision with blocks. We have a scrolling background. We have double jumping. I think that the last thing that we need to add here is the fire thing, right? Kind of that trap where you hit it and you kind of flash. And then once we've done that, we'll pretty much be done the tutorial. All right, so let's write our class for representing our fire. So I'm going to say class fire. This is going to inherit from object as well. And this is going to be animated, right? We're going to have animated fire. So this will take a bit more work, but I think it'll be worth it. It looks pretty cool on the screen. So I'm going to take X, Y, width, and height. And then I'm going to call my super initializer. So super dot underscore underscore init self X, Y, width, and height. Okay, and then for the name of this, I'm actually going to call it fire. Remember that we can pass a name. The reason I'm adding a name to the object is so that I can determine when I collide with the object if it's fire, and if it's fire, then I want to do something, right? Okay, so for self.fire, I'm going to use our load sprite sheets function. For directory 1, this is going to be traps, and for directory 2, this is going to be fire. Now, if we go here to traps, you can see that fire is one of our traps. So we have hit, off, on, okay? Now, there's also a bunch of other traps, right? So you can pick a different trap if you want. Like you could pass this blink one or whatever. The thing with these ones is that they have some more animations, so there's a bit more logic you need to handle for them. So that's why I'm going with fire, because it's a pretty simple one to do. Now, up here for fire, I'm again going to have my animation delay. So let's just make that equal to 3. And now let's specify our image. So let's say our self.image is going to be self.fire off. We're going to start with it off and then 0. Okay, then I'm going to say self.mask is equal to pygame.mask.fromSurface self.image like that. Okay, then I need to set an animation count. So I'm going to say my animation underscore count is equal to 0, just like we did for our player. And I need to set my self.animation underscore name, which for now is going to be equal to off. Okay, now I'm going to make a few functions. my first function is going to be on, or my first method. And I'm going to say self.animation name is equal to on. If we look at fire, we see we have hit, off, on. We're not going to use hit. We're just going to use off and on. Okay, now we're going to have off, self.animation name is equal to off. Okay, and then we'll have our loop. We'll say define loop, self, and inside of our loop, we're going to do a very similar thing to what we did inside of our player loop. In fact, so similar that I can copy pretty much all of this right here. So let's copy all that, and let's paste that here. Now, for update, rather than actually just calling an update method, we'll just copy the stuff from the update method here and just paste it down here. Okay, and rather than self.sprite, we're going to change this to image. And I actually think that once we remove the direction here, this is all that we need for our... All right, so now we just need to make a few changes. We're going to get rid of this sprite sheet name. And rather than sprite sheet name, we're going to say self.animation name. And now we should actually be good to just use this. So let me space this out a bit. We get our sprites, okay? Is it going to be self.sprites? No, it's not going to be self.sprites. It's going to be self.fire, which is this, okay? Really, I probably should have called this something else, but fire is going to represent all of our fire images, okay? So I'm using this to get my different animations. I'm getting the animation name that I'm currently playing, so either on or off. And then I'm saying my sprite index is equal to self.animation count divided by the self.animation delay mod the length of sprites, same as what we had before. My image is equal to sprites at sprite index, and then I increment the animation count, update my rectangle, and update my mask, which is important for the collision, and I'm good. Now, last thing I want to do here is I want to just check if my self.animation count is greater than, actually, if this divided by my self.animation delay is greater than the length of sprites. Now, the reason I want to do this is so that my animation count doesn't get too large. Now, you'll notice in my player class, I actually didn't do this. Now, that was intentional because if you do this, then it kind of messes up how the double jump works. You can do it if you want, but you'll see that it kind of messes with things. And with our player, we're constantly resetting the animation count when we jump or when we go left or when we go right, so that value doesn't really get too large. But here for our fire, since it's just static, like it's just sitting forever, what will happen is the animation count, if we never change it back to 0, will get to an extremely large number, which can kind of lag our program. So what I want to do is just make it smaller, right? So if it goes beyond what the actual animation, the length of the sprites are, then I want to set this to 0. It's important I divide it by the animation delay, though, because if I'm dividing it here, I need to divide it here before I set it back to 0. Okay, so now we have fire. I think that's actually all we need for fire. So now we just need to add it to our objects. So let's create it. Let's say fire is equal to fire. And what do we need to pass for fire? We need an X, Y, width, and height. So we can pick where we want to put this. Where do I want to put my X and Y? Okay, for now, let's go 100. And let's go height minus the block size. And then I don't know how tall my fire is going to be. I've got to see how big I want to make this. Let's make it, say, 64. And then we'll go 32, 64 here. Okay, so if we look at fire, let's quickly have a look here, and go to off, for example, or on. The size of this is 32 by 64. Okay, that's what the size is, and you need to pass that correctly to the fire class. Otherwise, it won't load the image properly. So we take our height minus our block size minus 64, which will put us on top of a block. Now, I will put this at, 100 is fine for now for the X. And 32 width, 64 height. There we go. We have our fire. Now I'm just going to say fire.on. I'm just going to turn it on. We'll just leave it on forever. You can turn it off programmatically if you want. And then inside of objects, I'll just place my fire. Now that I've done that, it should just show up on the screen when I run my code. So I got an issue. Let's see what the bug is here. Of course, the output is not showing up correctly. It says init takes from 5 to 6 positional arguments, which 7 were given. Okay. I see the issue here. Let's go back to our fire, and we don't want to pass self. Let's remove self. Okay, let's run this. List index out of range, self.fire off 0. Okay, I'm wondering why that's giving us an issue. We have off here, so that should have been okay. So let's go here and let's print self.fire, and let's see why it's giving us this this bug here. All right, so I've determined the issue, and the issue is that I passed the incorrect size here. It's actually 16 by 32. So I was passing too large of a size, and that's why it wasn't giving us the correct number of images. So let's change this now and run, and now we should be okay. And there we go. Now we have fire, but however, it is off. Now, the reason it's off is because we didn't call the loop method on fire. So let's fix that. I can also get rid of the print statement that I put here that I don't need anymore. Okay, so let's go down to main, and where we have player.loop, let's call fire.loop. And is it asking for the FPS? I don't know if I took that in my loop here. No, I don't need the FPS for that, so let's get rid of that. Okay, now let's call it, and it should start being on. Fire object has no attribute sprite. Okay, let's go fix that error. My apologies. Fire, we have sprite somewhere here that we don't want. Self.sprite. This is going to be self.image and self.image. All right, sorry about that. Let's run it now. And there we go. We now have a moving fire. And notice that I can kind of be on top of the fire, right? So I can collide with it, and it's like pixel perfect collision pretty much when I'm hitting it. So now the last thing we need is to just make it so we go into that kind of hit state when we do hit the fire. That's actually pretty easy to do. We just need to add a kind of state to our player to know if we're hit or not. So we're going to say self.hit is equal to false. We also want a hit count because we're going to only be flashing for a certain amount of time. Then we're going to have a method here, define hit self. Self.hit equals true. And self.hit count is equal to 0. Then we're going to go in loop. And before our update sprite, we're going to say if self.hit, then self.hit count plus equals 1. And then we're going to say if self.hit count is greater than, and we can just pick some value, but let's say FPS multiplied by 2, which is going to be 2 seconds. Then the self.hit is equal to false. Then we go here into our update sprite, and we say, actually at the top here, if self.hit, it's important you put this at the top, by the way, so make sure you put it here. Then we are going to say the sprite sheet is equal to hit. Great. Then we want to now determine if we actually got hit. So we do that from our collision functions, which are going to be here. All right. So we have collide left, we have collide right, and we're going to have vertical collide. Now what we're going to do is we're essentially going to loop through all of these objects, and we're going to see if we hit fire. Now, the way we'll know if we hit fire is by looking at all the objects that were returned here, and it will tell us, well, if we hit fire or not, right? It's because we can look at the name of the object, and if the name of the object is fire, then we know we hit fire. So I'm going to say toCheck is equal to collide left, collide right, and asterisk vertical collide. Now, I realized that inside of here, I only returned one object, whereas inside of here, I returned all the objects I was colliding with vertically. Really, we should probably be returning all of them from here as well, but I think this is still going to work, so we'll just leave it how it is for right now. So I'm going to say for obj into underscore check. These are all the objects we collided with, remember? I'm going to say if to underscore check and to underscore check dot name is equal to fire, then player.hit is equal to true. Okay. That is all we need. And actually, I'm going to say player.hit. I want to call the method. I don't want to set it equal to true. So what we're doing here is looking through all the objects we collided with. If any of them are fire, then we will put hit on the player. The reason I'm doing this first, if toCheck, is because these could be none, right? We could have no objects we collided with. So I need to make sure I handle that case before I try to access name on an object that isn't defined. All right, let's run the code and let's see. And player has no attribute hit count. Okay, so let's go to player and let's go to hit count and let's make that equal to 0. I guess I forgot to assign that. All right, let's try this now. List object has no attribute name. Okay, interesting. Let's see here. Okay, all right, so I'm using toCheck when I need to be checking obj. So let's fix that and run the code. Bool object is not callable. Okay, player.hit. Aha, so let's call this make hit. It's because I have an attribute with the same name as my method, so it's accessing the attribute when it should be accessing the method. So I'm just going to say make underscore hit, and now that should fix the problem for us. Run the code, and there we go. Now, it looks like I'm always being hit right now. That, of course, is a bug. So hit is equal to false. Let's check our hit count. It's because if self.hit count plus equals 1, if self.hit count is greater than self.hit equals false, maybe we need to reset our hit count as well. Okay. And there's probably a bug here. Let's scroll down, keep scrolling with our fire. So we have toCheck if obj and obj.name equals fire player.makeHit. Okay. Not sure what the bug is. Let me run this again. And yeah, it seems like we start out in the hit state. So maybe it's an issue in here. Let's have a look here. If self.hit, sprite sheet equals hit, but are we hit right away? For some reason, it's making us hit immediately. Okay, let me have a look here, guys, and I'll be right back. All right, so I've realized I made a silly mistake here. I accidentally had this collided objects append outside of this if statement, and that was causing all kinds of bugs and issues for me. I think I was doing some print debugging, so let me get rid of that here. Anyways, I just moved it back now so that it's in the correct location. So now if I rerun this, now we should see that when I hit the fire, it puts me into kind of this hit state, lasts 2 seconds, and then it ends. All right, so with that said, guys, I think that's pretty much going to wrap up this video. This showed you how to create a platformer, how to do animations, how to do sprites, how to do a scrolling background. Obviously, there is a ton of stuff that could be added to this game, but I really want to leave that to you. Obviously, I could spend hours, days, months working on a game like this, but I think this is a solid enough base to really give you guys a good foundation to go out there and create something pretty cool. Obviously, there's all kinds of assets that I will leave in the GitHub that you can use. I have all kinds of other Pygame tutorials that you may want to reference if you want to learn about menus, sound effects, points, scoring, all of that kind of stuff. You guys just go on my channel, search Pygame tutorial. You will see a bunch of them. Those will show you how to do a ton of other things that you may want to add to this game. So I hope you guys enjoyed this. This was a ton of work. As always, the code will be in the description. If you did enjoy, make sure to leave a like. Subscribe to the channel, consider supporting me by purchasing something like Programming Expert, and I hope to see you in another YouTube video.